Okay, so for this session, we're going to discuss the second topic for our end semester 2 test, which is about probability. Okay, let's just go to the questions. Okay, so question number 6 in here: a fair coin is tossed one. What is the probability that it will show a tail? So, as you know that if we write down the general formula of probability, so the probability of event A is just equals to the number of event A that will happen divided by the number of samples, right? So what does this mean? It means that if A is the event that it will show a tail, so I can write down as P tail, right? Because event A is the event where tail is going to be shown in here, and then the NA means the number of tail that you have. Remember that in a coin you only have like two sides, the head and the tail, right? So the tail in here is only one, right? You only have one tail in a coin, so it's just one. And then NS means that the total of samples that you can get, because we know that we have two coins, two coins, two sides in one coin, so which means that the NS is equals to 2. So actually this is the final result, or if you want to write it down as a decimal, you can write down 0.5, or you can write down as a percentage, but most of the time we're going to use fraction in this one. Okay, so that is for number 6. Okay, number 7. A fair die is thrown once, yeah, once. What is the probability of getting an odd number, getting a number less than 3, and getting a number of more than 6? Okay, so most of the time when we want to find out all of these questions, when we want to answer all of the question, we need to determine what an S means, right? So it's the cardinal number, or the number of possible outcomes that we can get from throwing a die once. Okay, so a die has a 6 sides, right? Because we know that it has 6 sides, and all of them like have like in each side they have like numbers like a dot, but it's said like 1 2 3 4 5 6, right? So which means that the ns is equals to 6. So this is the first information that you can get from throwing a die once. Okay, and then for question A, it means that for question A we have PA, right? The event of A is getting an odd number. Okay, so as you know that the outcomes of throwing a die, you can have an outcome of 1 2 3 4 5 or 6, right? So these are the outcomes that you can get from throwing a die once. And then it said that it's getting an odd number. So which of these number 1 2 3 4 5 6 are odd numbers? So as you can see that this one is odd number is odd number. So which means that the NA is going to be equal to 3, because we only have 1 2 3 odd numbers. Since we know that the number of possible outcomes, there are three number of possible outcomes, which are 1 2 and 1 3 and 5, right? 1 3 and 5 are the possible outcomes if you want to get an odd number, right? We have 1 2 3, we have three of them, right? So it's just going to be equal to 3 out of 6, because we know that the ns is equal to 6. And you can simplify this number by dividing both of the numerator and denominator by 3. You will get 1 over 2. Okay, so for the next question is getting a number less than 3. Okay, again, we are using the same outcomes. The outcomes, the possible outcomes to entering a die is just 1 2 3 4 and 5. 1 2 3 4 5 and 6, right? And then you can say that how many outcomes that we can get if it's less than 3, right? So I'm going to rewrite that. I have 1 2 3 4 5 6. These are the possible outcomes from throwing a die. And then you pick the number that is less than 3, right? Less than 3 are like this one and this one. This one doesn't include because it's not less than 3, it's equal to 3, right? So which means that if I write down in here, okay, so for this question B here, it means that it's going to be P, the event of B, right? Because it's going to be, because it said that less than 3, and as we know that the numbers that is less than that are less than 3 in this case, right, for these outcomes is just these two numbers, 1 and 2, right? So which means that n b, the number of outcomes of getting less than 3, is equal to 2, because we only have two outcomes. So that is means that it's going to be 2 over 6, right? The 2 is from here and the 6 is from here, okay? And simplify this, we can divide both of the numerator and denominator by 2, so we get 1 over 3. Okay, the last one for number 7, the C. It's getting a number more than 6. Okay, so I'm going to rewrite the outcomes again. 1, 2, 3, 4, 5, and 6. And then it said that PC, right? So the probability of getting event C, which is getting a number more than 6. As you can see here, we don't have any number that is more than 6, right? So, which means that the number of outcomes of getting more than 6 is 0 because we don't have any value in for the outcomes, h which is more than 6, right? So it's going to be 0 over 6 is just equals to 0. This is for number 7. For number 8, the question, a container holds 15 red, so it should be red, 15 red, 5 gold, and 25 blue marbles. Okay, so can a container have those marbles, those colored marbles? And one marble is randomly taken from the container. It's random, okay? So the question is, what is the probability that we have? It's a red, it's a blue, or it's a non-blue? So again, like the previous question from number 7, the thing that we need to write down here first is the number of the total outcomes, right? So we can say that the number of total outcomes, right, and S, which is a sample in here, in this case, is 15 plus 5 plus 25, right? We have 15 here, 5 here, and 25 here, right? So 15 plus 5 is 20, 20 plus 25 is equals to 45. So this is going to be the NS, or the number of samples in this, the total sample or the total outcomes from this case. Okay, so let's go to question A. Question A said that we have a probability of getting a red marble, so I'm going to write down that as P red, right? Because it said that it's a probability of getting a red, so which means that it's gonna be very easy, guys. So it means that it's going to be the N of red and then over N S, right? As you know that we have 15 red marbles here, right? So which means that the N red is just 15. And then NS is going to be 45 from this number over here. Okay, we can simplify this by dividing both of the numerator and denominator by 5. We'll get 3, is it 5? Okay, divide both of them like by 15. I can get 1 over 3. Okay, so this is the final question, final answer for question 8A. And then question B, it said that it is a blue marble. Okay, so the same exact thing what we do for number 8A. So P for blue is just that the number of blue that you have and divide that by the total of marbles that you have in the container, right? So the N blue here is 25 because we know we have 25 blue marbles, and in NS is equals to 45. And 25 over 45 can be simplified by dividing both of the numerator and the denominator by 5, right? So divide that by 5. 25 divided by 5 is 5, and 45 divided by 5 is equals to 9. So it's 500. Okay, the last question for number 8, 8C. It's said that it is a non-blue marble. Okay, so it's P of non-blue. Non-blue. It means that it's not the blue, right? The blue one is this one, right? So we are excluding this, right? So the number of non-blue, which means that we're going to have the red and the gold, right? And which means that the N of I'm gonna write down here. The N of non-blue divided by NS, right? Non-blue is the are the red and the gold, right? So it's going to be 15 plus 5 because we have 15 red and 5 gold, okay? And then divide that by the NS is going to be 45. And then let's calculate that. 15 plus 5 is 20. And over 45, I can simplify that by dividing by 5 for both the numerator and denominator. I will get 4 over 9. Okay, so that is for number 8. Okay, next for number 9. Two fair dice are thrown once. What is the probability that the sum of the numbers from the dice is A 4, B less than 3, and C at least 9? Okay, again, that I said before, guys. The first thing that you need to do is to calculate the total number of outcomes in here. And here we have two fair dice. Okay, two fair dice. Okay, so which means that the outcomes can be like from two to the two dice. If we add them, the outcomes can be can be written as a table actually, right? 1 2 3 4 5 6 and 1 2 3 4 5 6, and then you make a table like this, right? Like this, and then you write down the outcomes by adding these two numbers, right? So it's like this one is 1 plus 1. Should we have one more like this? So this one is 2. Why is it 2? Because 1 plus 1 is equal to 2, right? And then this guy is 3 because 2 plus 1 is equal to 3, and so on and so on and so on. So I'm gonna fill all of the numbers here. So I have 3 and then 4 and then 5 and then 6. Is it? Yeah. And then 7 and then 8 and then 9 and then 10 and then 11 and then 12. Okay, so these red numbers are the sum of these two dies. Okay, so let's say this is the first die and this is the second die. Okay, so if I have two dies, the red numbers that I fill in the table is the sum of that two numbers. Okay, so in here, if we calculate how many outcomes do we have, the NS, right? The NS is going to be equal to 36. An easier way to see this is like a square, right? So like 6 times 6 is equal to 36, right? So although it's not exactly like a square, I mean, like, I'm not drawing it like a square, but it is a square actually if we draw it in a good manner. Okay, so yeah, it doesn't really matter for that. For in here, which means that the NS, or the samples that we can get from throwing two dice at once, is 36. There are 36 total of outcomes in here. And in here, for question A, it wants to get a 4. The sum is equals to 4, right? The sum of 4, how many, you only need to calculate how many outcomes does 4, I mean, like, how do I say it? How many how do I say that? How many 4s is in the table? Okay, but the red one, because we know that the sum is the red one, right? So we have this one here, this one here, and this one here, right? Okay, so we have like these three numbers, and not three numbers, yeah, 3 of 4. So which means that is the n, which is the sum is equals to 4 divided by the ns, right? So because we know that if we add, we see that the 4 comes up 3 times in here, this one, and this one. So it's just 3 over 36. I can simplify this number by dividing both by 3. I will get 1 over 12. Okay, so that is for question A. Let's go to question B. It's less than 3. Okay, so P, the sum is less than 3. Less than 3 means it can be 2, it can be 1, it can be 0. Okay, but here we don't, it isn't possible that we'll get a 1, right? So the only possible outcomes for this case is just this one here, right? Because it said that's less than 3. Be very careful, guys. When I say less than, it means that 3 does not include it into the calculation. Okay, so this 3 is not included because it's less than 3. It said less than 3. Okay, so the only outcomes that we can see is this one. So only one of that, which is, so I'm just going to write down 1 over 36. Okay, the next one is C, for question C. P is set at least 9. at least 9 means it means that the 9 does include into the calculation, okay? Because it said at least 9 means 9 can be, yeah, you can have 9, but you cannot have 8, right? But you can have 9. You can have in here like 9 and then 10 and then 11 and then 12, maybe 13, but we don't have any 13, right? So in here we have at least 9 means that, oh, we can have these numbers, right? Right? I can get 9, I can get 10, or I can get 11, or I can get 12. Okay, so at least 9, so I can write it down like this, guys. So how many outcomes do we have in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's just 10 over 36. I can divide both of the numerator and denominator by 2. I'll get 5 over 18. Okay, for number 10. There are 6 purple and 10 blue marbles in a basket. Okay, 2 marbles will be taken one by one without replacement. Okay, so pay very close attention to the words. Okay, to the to the sentence. Okay, so it will be taken. 2 marbles will be taken one by one. It said this is the keyword here. We have without replacement. So if you take one, you don't put it back into the basket. Right? You take one and then you take another one from the basket, but you don't put the first marble that you get into the basket again. Okay, so that's being said without replacement. Okay, the question is, what is the probability of getting both purple marbles? Okay, so let's go to the A. Okay, so question A said that both of them blue marbles. So in here, guys, we have more than one event. Okay, you have 2 events. The first event is taking 1 marble, and the second event is taking another marble, but without replacement. Okay, so I can say that this is like event number 1 and then event number 2. Okay, so event number 1 is like it said that getting both blue marbles. It means that you'll get blue marbles in here, and you also get a blue marbles in here. But pay a very close attention. I'm gonna write down 1 and 2 here. Okay, so pay a very close attention. It means that if I take the first one is blue, which means that the probability just like, I forgot to write down the NS, guys. So the NS, okay, the NS is just 6 plus 10, right? Because we have 6 and 10, which is equals to 16. Okay. Okay, so let's go back. So the probability of getting a blue marble from the first time you take it, when you take it at the first time, is 10 over 16, right? 10 over 16, because we have 10 blue marbles and then you have a total of 16 marbles in the basket. Okay, so that's the first one. The second one here, it's be very careful, guys, because when you take the second time, right, because it's without replacement, it means that you don't have 16 marbles, right? Because you have taken 1 marbles, then you only have 15 marbles when you take for the second time, right? The second time you take it is 15. We have 15 total of marbles. And because you have already taken the blue marbles, assuming that you have blue marbles when you take it for the first time, which means that the blue marbles is also reduced by 1, because it is assumed that you will get a blue marble when the first time you get it. So it's going to be 9, right? Because 10 minus 1 is 9, and 16 minus 1 is 15. Okay, so when it say like this, actually it's like when we connect this to event, we can say that we have this guy and this guy. So if we see this connection, you are going to be multiplying these 2 numbers. Okay, so yeah. So in here, guys, I suggest that you, if you can, what do you call it? If you can simplify the fraction, you just simplify it, right? Okay, I'm gonna simplify that. I'm gonna divide this by 2. I get a 5. Divided by 2 is 8, and I'm gonna divide this by 5. I'll get 1, and then this is 3. I'm going to also divide this by 3. I get 3, and then this is 1. So if I multiply these 2 numbers, it's just equals to 3 over 8. Okay, so that is for number 10A. Okay, let's go to number 10B. Basically, it has the same exact concept. Okay, question B. I'm gonna use this one. Okay, getting both purple marbles. Okay, so exactly the same thing like we did like for A, but this time is you're going to use the purple marbles. Okay, so event 1 and event 2. Event 1 is getting a blue, purple marbles. It will be 6 over 16. Why? Because we have 6 purple and we have 16 total of marbles. That is for the first time you take the marble. If it's if you expect that to be purple, okay, and because it said that again without replacement means you don't put it back, you have already get one purple marble. You are assuming that you get a purple marble at the first time you take it, right? So which means that the purple marble will be reduced by 1, so it's 5, right? 6 minus 1, because you have taken 1, is going to be 5. And the same thing with the total of marbles, because previously we have 16 marbles and then you have already taken 1 marbles, so this is going to be 15. Okay, again, you just multiply and you can simplify. Divide by 5, I get 1 over 3. Sorry, 1 over 3. And I can simplify this. Divided by 2, 3 over 8, is it? Okay, and then I can yeah, I can just like cancel this and I will get 1 over 8. Okay, so there we go. We have the event of getting both purple marbles. Okay, so let's go to the next one. Let's see. I'm gonna put it here. Okay, so this time the event 1 and 2, here we have getting 1 purple and getting 1 marble. So actually, guys, we have two possible events. Okay, events, a pair of events. Okay, the first one, you might get a purple first and then you get a blue marbles. Okay, and the second one, maybe you can get the first one is blue and the second one is purple. Both of them works okay. Okay, but you need to calculate the probabilities of these two pairs of events, and then you add the probability. Okay, so let's go to the first one. If you get the first one as a purple, then you will get 6 over 16, right? Because we have 6 purple from the total of 16. Right, and then the next one is after you get that purple, right, you get a blue marble in here, right? So because we know that we have 10 marbles and none of the blue marbles has been taken, so it's 10 over 15. So why is it 10? Why is it not 9? Because we assume that the first time we take the marbles is the purple one. It means that the blue one is still 10, right? There are still 10 blue marbles inside the basket. Why this one is 15? Because we have already taken 1 marble from the first time you take it, right? And then which means that you subtract that by 1 is going to be 15. So if I calculate this and I can just like divide this by 5, I get 3 and then I get 2. And divide this by 2, I get 3 and 8. And I'm going to cancel this 1 and 1, right? And then I'm going to cancel this, and I will get 1 over 4. Okay, so, and then you do the same thing with this one. Okay, the second one. This is the first one, and then this is the second pair of events that also fulfill getting 1 purple and 1 blue marbles. So which means that when the first time you take the marbles, you will get the probability of blue is 10 over 15. Sorry, 10 over 16. Right? You get 10 marbles, 10 blue marbles, and then you get a total of 16 marbles in the basket. And then you multiply that by the purple, because we know that we have 6 purple and none of them has been taken from the first time you take the marbles, so it's still 6, and then divide it by 15 because it's reducing, because it said without replacement, it means that the marbles will be reduced by 1, so it's 16. So basically, guys, you're just like doing this, and I will get 1 over 4 also. Okay. Okay, just cancel this, right? 3 and 2. Cancel this. And 3 and 8. Cancel, 1 over 4. Okay, so because we have two of possible outcomes, right? That 1 over 4 and 1 over 4, so which means that the probability of getting one purple and red, sorry, red is blue, is 1 over 4 plus 1 over 4. 1 over 4 from this one. All right, I'm gonna change the color maybe. Yeah, so I'm gonna get like equals to 1 over 4 from here, and added that with 1 over 4 from here. So it's going to be 2 over 4, or I can simplify that equals to 1 over 2. Okay, so for the last number 11, I'm going to read the question. A survey was conducted of 100 students who buy lunch at Math is Fun High School. 55 of them like pizza, 70 like burgers, and 30 like both pizza and burgers. And the following Venn diagram shows the event of likes pizza and likes burger, like this one here. And we have those letter P, R, Q, and S, right? And the question is, the first question, what is the value of PQ and the value of R and S? Okay, so actually you can answer, I mean, like, you can choose which one do you want to answer first, okay? Is it like the Q or the R or the S or the P? Okay, so if we go back to the Venn diagram from grade 8, I think it's a grade 8 or grade 7, I forgot. In terms of Venn diagram, the easiest way if to fill the numbers in here is this one over here, the one in the middle here, this one, right? So that represent the intersection of the two possible outcomes, which is like the like pizza and burgers, right? So because we know that we have, which means that this here, the number here, is the number in which it's included both like pizza and like burger. It means that Q is the number in which the number of students who like both pizza and burgers. And we know that from the question we have this number over here, right? So the 30 here is like represent the number of students who like both pizza and burger. So I'm going to write down 30 over here. Okay, so that's the first one. The second one is let's pay attention to this circle over here. Okay, that circle over there. And as you can see that sorry guys. As you can see, guys, that is because we know that there are 55 of them who likes pizza, but we know that 30 of this 55 likes both also likes burger, right? So which means that the number in here should be the subtraction of 55 and 30. 55 minus 30 is equals to 25. Okay, come into logic, guys. These two numbers, if you add up, is going to be equals to this one, right? 25 plus 30 is equals to 55, right? So that's the first one. Okay, so do the same thing with the one on the right side, which is like burger. This circle over here, right? And as you can see that there are 70 students who like burgers, but from this 70 students, okay, 30 of them also likes pizza. So which means that this one over here is just 70 minus 30 is going to be 40, right? 70 minus 30. As you can see here again, guys, the number here, if you add it, it's going to be equals to this one, because in this green circle here is representing the number of students who likes burger. I'm gonna make it a little smaller here. Okay, so the next one, we have another number in here, guys. As you can see here, that you have 100 students, right? The survey should have 100 students in here. So let's check. Do we have 100 students in here? Okay, so 25 plus 30 is 55, and then you add it with 40, you'll get 95. But it said here you should have 100 students, right? So you're lacking a 5 student, right? So which means that this P right, is going to be 5. Okay, let's check it again, guys. If you see here, the numbers, if you add all of these numbers, they should add up to 100 students. 5 plus 25 is 30. 30 plus 30 is 60. 60 plus 40 is equal to 100, right? So these are the value of P, Q, R, and S. So we can answer this one like this. Okay, so the next question is, it's still related to this one, but this time it's going to be a question about probability. So basically it's the same thing. Okay, so for C, first question C, it said that what is the probability a student is selected random from this survey, right, from the class of the survey, 100 students. What is the probability that this student likes pizza but does not like burgers? Okay, you can just see it from the diagram. Which of those numbers, 5, 25, 30, 40, are the numbers of students who likes pizza but does not like burgers? Okay, so like pizza is these two, right? 25 and 30, both of those two numbers likes pizza, but in here they like pizza but doesn't like burger. It means that this is not going to be included because this 30 also like burgers, right? So which means that the probability of getting students who likes pizza but does not like burgers is 25, from here 25 over 100. Where do I get this 100? Because we have 100 students in here, right? So it's 25 over 100, or I can simplify this as 1 over 4. Okay. Okay, so the next one, D, is likes burger but does not like pizza. So it's the same thing, but this time they like burger but does not like pizza. So if I can see from the diagram, is this number over here, right? So this 40 likes burger, but this 30 likes burger but also likes pizza, right? So that 30 would not be included. Okay, so which means that the P, the probability of event D, is 40 from here over 100. 100 is from here. Okay? Okay, over 100. Simplified as divide both of them by 20. Just cancel this, right? Cancel the 0. I'll get divided by 2 is 2 over 5. Okay, question E. Doesn't like pizza at all. Okay, so this guy, this 25, likes pizza. This guy likes pizza and burger. It means that it's also likes pizza, right? This guy doesn't like pizza, right? Only like burger. And this guy doesn't like pizza and doesn't like burger. So which of those numbers who do you think that it doesn't have any pizza on it? Right? Is this that like this 40 and 5, right? Because that 25 and 30, both of them has pizza on it, right? This is pizza and burger. This is just burger. This is doesn't like pizza, doesn't like both of them, right? So which means that the number of student who doesn't like pizza at all is that 40 and this 5, right? So I can write this down as P event E is going to be equals to 40 plus 5, right? Because we have 40 student who likes burger only and doesn't like both, which is 5, and divided by 100. Again, the 100 is from here. Okay, so this is going to be 45 over 100. I can divide both of them by 5. I will get 9 over 20. Okay, the last question for F. Doesn't like both pizza and burgers. Doesn't like both of them. So this one likes pizza. This one likes pizza and burger. This one likes burger. This one doesn't like both of them. So it means that it's going to be this one guy, right? So the probability of event F is going to be 5 over 100. Divided by 5, I'll get 1 over 20. So there you go.